Hey, it's Mrs. Wisniewski.
Hey, it's Mrs. Schulte,
and we're shifting parabolas. Have you ever wondered why sometimes your parabola is in the middle of your calculator? Sometimes it's off to the right, sometimes it's off to the left, it's upside down. Well, today we're going to talk about why that is. So what you have on your notes is you have the most basic quadratic x squared, and it's graphed for you. And you are being asked to sketch this graph right here. So we realize that you don't have a graphing calculator, so I'm going to give you the points that you need in order to graph it. Okay, so we're going to go from -1. So you should copy these down if you want, or just start graphing the points. Okay. And if you see, oh, excuse me, here's the rainbow. Right. Now, I would like for you to pause the video and graph this function g of x. And now that you're back, your graph should look like this. Now, the question is asking, how would you need to shift the graph of f of x to get to g of x? So f of x is our original, this guy here. They want to know, how are we getting to this new graph? Well, I'm going to use the vertex. Looks like I'm going 1, 2 units right. And 1, 2, 3, 4 units down. So now, every point, you should be able to count 2 units right, 4 units down, and you end up with the new point on the new graph. So that's the transformation.
Okay, so we have the most basic quadratic function again, and what we're going to do is sketch the next two quadratics. Because you don't have a graphing calculator, I will give you the chart again. You can begin plotting these points if you'd like. So these are the points for y equals x squared plus 2. Mrs. Wisniewski, how are you? I'm just fabulous. Okay, so these are our coordinates for the first quadratic, and here are the coordinates for y equals x squared minus 4.
You're better at that than me.
I thank you. Okay, I want you to pause the video and graph both functions. Okay, looks amazing. So now what we're going to do is we're going to time out. Yeah, so here we go. This one is your answer for y equals x squared plus 2, and your other graph should look like this. Okay? And what we're going to do is answer the question, what is the effect of adding a constant to the overall function? So what we notice is that when we added 2 to x squared, our parabola shifted up. When we subtracted 4 from x squared, our parabola shifted down. So when you add, it shifts up, and when you subtract, it shifts down.
Okay, so we're going to do one more. Again, we have the same basic graph, which is y equals x squared again. And now we're going to talk about shifting to the right or the left. And if you see, the 3 is just being added to the x,
in the first example, and the 1 is just being subtracted from the x, not the square, not the whole thing. So again, we're going to give you the charts to graph it. Okay, so this is for the first one, x plus 3 squared. And negative 5 goes with 4. Negative 4 goes with 1. Shh. Negative 3, 0. Negative 2, 1. Negative 1, 4. Okay, that's the first one. And the second one, oh yeah. Don't be jealous.
I am jealous.
Yeah, I don't think so. Negative 1, 0. I should be a comedian, don't you think?
I think so.
Yeah.
Mrs. Wisniewski, it has to be a 3.
Okay, I don't know how to erase, so it's just going to be 3. 4, 1, 0, 1, 4. 0, 4. And just a reminder, if you were doing this on a calculator, there's the rainbow, right? Or the coffee mug. Okay, so please pause, graph, and take note of what's happening if it's moving right or left. And we're back. So you notice we moved right or left, and you may have noticed that when we add 3, we're actually moving to the left. And when we subtract 1, we move to the right, which the word we use for that is counterintuitive. And basically, it's moving the opposite way that you'd think it would move. You'd think a minus would move to the left, a plus would move to the right, but it doesn't. Okay, so a minus, yeah, that's not a minus. Let's do a plus first. Plus is to the left, and a minus is to the right. Got it? Good. So, in the summary, we're going to talk about what this means in the equation. So the thing that I just showed you was what's being added or subtracted to just the x, which is this guy here. So this is your horizontal shift. So this is minus to the right and plus to the left. This is the one that's counterintuitive. It's backwards. Mrs. Schulte, what color would you like?
I would like to do purple.
I knew it.
Thank you, Mrs. Wisniewski. The shift that we spoke about is the vertical shift. Vertical shift. And when it is negative, it's down. And when it is positive, it is up.
So these shifts that we just talked about only work when the equation is in vertex form. Well, how do you know it's in vertex form? Because we're used to dealing with things in standard form, but it has to be in vertex form. Well, how do you get it in vertex form? Or how do you know when it's in vertex form?
This looks really familiar. It looks like, oh wait, it is, completing the square. So before you take the square root, we're going to bring the constant back over. So if I have x minus 2 squared equals 4, my 4 is the constant. So to bring it back over to the side where the quadratic is, I will subtract my 4. And now I have x minus 2 squared minus 4 equals 0.
Vertex form.
Vertex form.
Cool.
Okay, let's review what happens to the parabola when the leading coefficient is not 1. Remember, when a is positive, the parabola turns up like a cup or a smiley. When a is negative, the parabola turns down like a frown.
Okay, so what I want you to do right now is to match the parabolas on the left, 1, 2, 3, or 4, and number them where you think they are on the right in the graph. Thinking about it logically, it looks like it's stretching or shrinking, right? So I would identify number 4 first, where the x squared is, and go from there. Pause the video and please do so. Okay, so number 4, you can see how it's labeled, and I would go from there. And what you're seeing may be the opposite of what you thought. Number 1, the 3x squared, is actually smaller than x squared. And number 2 is actually larger. And if you had a calculator, you could put these in and see. Now, numbers 3 and 5 are the ones that are upside down, like a frown, because they have negative leading coefficients. The negative x squared should be the exact opposite of x squared. And then the negative 2 is slightly smaller. So this is also, in a way, counterintuitive, because the number in front, if it's greater than 1, it shrinks it. Put a star in your top right-hand corner for 2 extra bonus points.
Oh my god.
And here's a little something creepy for you.
We look forward to seeing you tomorrow.
Bye.
Bye.